Hey, Matt, can you hear us?
Yes, ma'am. Good morning.
Perfect. Okay. Do you want to give me the new title of your presentation?
Absolutely. What they've got is continuous insulation for code-compliant, high-performance walls in type 5, the letter V, and residential construction.
Okay. So what we'll do is I'm going to give a quick intro into how this works, and everyone's muted. Your sound sounds great, so don't worry about that. And then I'll turn it over to you for a bio intro. And then
Okay.
you can, I'll just make a note that today's presentation is a little different, and you'll go over the title and a quick explanation. We'll still issue the ICC certificates to everyone, so that's not a problem. And then I don't know if you have sent over a copy of your slides yet in a PDF form, but if you don't mind doing that, we typically send that out to the participants following the webinar. They just like it as reference materials, and they're always asking for them. And then if you're okay with it, we will probably put this on our YouTube channel so people can go back and kind of watch and hear what you said.
Okay.
Great. Okay, so let's test the screen share. If you move your mouse at the bottom, it's a little different from GoToWebinar. You have to take control. So there's a green share button. And if you click that, I will let you know if I can see your screen, and you can just go ahead and keep it up. Yeah, do you want to try to put it in presentation mode? And then flip through once. Yeah, that looks great. Perfect. That is good to go. I will go ahead and start the broadcast. You'll hear me talk. I'll mute myself just to let people have a few more minutes to hop on. And then we'll get started.
Sounds like a plan.
Perfect. Thank you. I'm going to start this. And that's what kicks it off. And you'll see. Good morning, everyone. This is Liz John and Marielle Kramer with Spear. I have 8:30, but we're going to give just a few more minutes. I see people still hopping on. Grab your coffee, and I will be back in a minute or two to get things started. All right, good morning, everyone. I think I see a lot of participants on, so let's get started. Thank you for joining us this morning. As most of you know, or if not, we're going to start offering these webinars once a month just to keep the quality and the content new and relevant. And Spear is a nonprofit that works to advance the energy efficiency in Texas and Oklahoma. And many of you are regulars, so you know that our Energy Code program promotes compliance with state energy codes. And we do this through training, outreach, and peer support. And as a part of that mission, we bring you these Energy Code webinars now once a month on Wednesday mornings. So today we have Matt Stevens with PIMA, and he will be presenting on a similar subject, but the title that we originally had sent out is just a little different. He will be presenting on continuous insulation for code compliant high performance walls in type 5 residential construction. A few notes about this webinar. All attendees are muted. If you have a question, please type it into the Q&A panel. We will get to it at the end of the webinar, and if by some chance we run out of time, I will go ahead and send your question directly to the speaker, and he'll be able to get back to you directly. These webinars are ICC certified, so if you're watching right now, we will issue a certificate within the next several days. After the webinar, as many of you know, we'll send out an evaluation survey, and if you could complete the survey, then you will be receiving your ICC CEU certificate. So with that said, Matt, if you want to go ahead and introduce yourself, we can get started.
Thank you, Muriel. As Matt Stevens, I'm actually with RMAX, which is a PIMA member. Today we'll be doing a presentation on residential and type 5 construction, but if you have questions regarding anything commercial type 1 through 4, I'm more than happy to answer those as well, preferably offline through email and such. But I've got about 20 years in the building community, got my master's degree in architecture from Texas Tech, and worked for architecture firms, developers, even an exterior wall consulting company for several years before coming to RMAX about 7 years ago. So really enjoy what I do, very passionate about it, and hope we can educate you on some things and get some questions you might have answered towards the end. So we'll go ahead and get started with the presentation. This is an AIA accredited course. I think most of the folks online are going for the ICC accreditation, so I won't go into too much detail on that. But the course description, we're going to talk about the continuous insulation, or a lot of people just refer to it as CI. Many folks think CI is a brand new concept, and it's really not. It's been around for a while. We'll get into that. We're going to go into some applications utilizing continuous insulation, energy code compliance, building code compliance, and some installation detailing. So we hope you gain a good understanding of the use, properties, and the benefits of foam sheathing as continuous insulation. At the end of the course, our goal is for participants to be able to define continuous insulation, the role of continuous insulation, types and properties of continuous insulation. Also to identify some of the applications. It can be not only your thermal insulation, but continuous insulation can also act as a water-resistive barrier, an air barrier, sometimes even multifunctional with composite sheathing, where we are adhering OSB or plywood to continuous insulation for a variety of reasons. We want to help you understand energy code compliance, including prescriptive path, performance path, U-factor alternative, understand building code compliance. We'll go into a little bit about fire, structural, bracing, wind pressure, cladding, and at the end we're going to hit on some building science topics, circling back to that WRB, air barrier, touch on vapor retarders, moisture control, all these considerations we do when we design a building. Each of these topics will be a separate section. Continuous insulation applications, we've really kind of hit on those, so I'll move forward. Just a quick little history about PIMA. PIMA represents the polyiso insulation manufacturers and industry suppliers. PIMA's mission is a unified voice for all rigid polyiso industry members. We're an advocate for safe, cost-effective, sustainable, and energy-efficient construction, provide leadership, advocacy, and education, much like today's course. If you're curious more about PIMA, you can go to polyiso.org to get more information about that. So what is CI? Why should we be learning about it? It's a concept that's been in use since the early 1900s. Probably if any of you have worked in commercial construction, it's been in roofing in low slope commercial roofs since the mid 1900s, 1940s. Polyiso or just continuous insulation in general. The insulation is typically located above the roof joists in those applications. So CI wall applications in type 5 and residential construction are going to be the main topic here, but again, if you have any other questions, let us know. just reviewing the different types of construction. You have type 1 and type 2 construction. This is where the exterior and interior building elements must be non-combustible materials. Type 3 construction, the exterior must be non-combustible, but the interior may be anything permitted by code. You have type 4 construction, heavy timber. Exterior must be non-combustible, but the interior may be solid or laminated wood without concealed spaces. And then type 5 construction, the exterior and interior building elements may be any permitted by code, which would include wood and other combustible materials. So there are solutions to utilize continuous insulation in all types of construction. And a lot of the principles we're going to talk about today are going to be able to be applied to types 1 through 5 construction, but we're going to focus a little bit more on that type 5 construction type. Foam plastic sheathing, or FPIS as it's sometimes referred to, it's widely used and cost effective. Certainly many people are familiar with it in roofing applications. It's been used in mass wall construction, your CMU and concrete, for many years, but the codes now are starting to push for it to become part of your stud construction, whether that's steel stud or wood stud construction. Through the years, it's become more and more environmentally friendly. We have a responsible impact on the environment. We want to not only save energy, but also be responsible in our manufacturing techniques. And it can be used for a variety of construction types and applications. Everything from roofing, walls, below grade, really the possibilities are pretty endless. So there's 3 main types of foam plastic insulated sheathing. You've got EPS, or expanded polystyrene, and that's governed by ASTM C578. You have extruded polystyrene, or XPS, and that's also governed by ASTM 578. And then you have polyisocyanurate, often referred to as polyiso for short, and that's governed by ASTM C1289. So the ASTM standards, they govern the physical, structural, thermal properties of these materials. They ensure a product's performance is up to par. And oftentimes manufacturers are going to make products that are going to exceed that minimum level and be well above par. Some of the key attributes of polyiso, it's going to have the highest R value per inch of thickness of your insulation products out there. In your wall applications, ASTM requires R6 per inch, and some of your polyiso manufacturers are going to have higher than R6 per inch. Moisture resistant, it's not a food source for mold. Most moisture tests, it's going to have less than 1% moisture absorption by volume. It's compatible with adhesives and sealants. It's what's known as a thermoset material, so it's not going to react to chemicals and adhesives and melt or delaminate. It has excellent dimensional stability. It's not going to, again, it's a thermoset, so it's not going to return to a liquid state. That also helps it with its superior fire performance. The service temperature, it can go -75 all the way to 225 degrees Fahrenheit. And those are just conservative numbers. It can go higher, but those are what most of the polyiso manufacturers are going to list on their data sheets. It's also got long-term R value. Many of the manufacturers are going to have 15-year thermal warranties on the R value. It's got some recycled content in it, 0 ozone depletion potential, and virtually no global warming potential. Again, as I mentioned, through the years, polyiso manufacturers have really honed in on making the product more and more environmentally friendly. The definition of continuous insulation is insulation that's continuous across all structural members without thermal bridges other than fasteners and service openings. They recognize, obviously, we have to attach the insulation and we have to attach the cladding that's going to go over the insulation. And certainly we have to bring air and other utilities in and out of the building. So there have to be a few openings, so to speak, but nothing too crazy. You wouldn't want to have, metal Z-furring or, large brick angles penetrating through your continuous insulation. That would violate the definition that ASHRAE gives for continuous insulation. We mentioned the three main types of foam plastic insulated sheathing: EPS, XPS, and polyiso. Some of you may also be familiar with other types of insulation. There's a spray polyurethane foam, or SPF, also a closed cell material, and it's a closed cell polyurethane. And then some of the others that we often see go maybe in between studs on buildings are mineral wool, fiberglass boards, or fiberboard. Some of the roles of continuous insulation, certainly because it does reduce the amount of energy used by a building, it helps satisfy green build and sometimes even exceed it. There's fire requirements that can be satisfied by continuous insulation. In some cases, it can be even left exposed to the interior of the building and pass a room corner burn test. Moisture requirements, it can act as your WRB. It's also a very low absorbing product, so lots of advantages there. Practical, it can be easily put under siding installations and things like that. It's economical and affordable, and it can even, in some cases, be structural. Some of these boards are attached to structural components, so it can give you the same shear value that you would expect from other structural components. Now, looking at some of the R values of the different foam plastic sheathings out there, you have EPS, again, that expanded polystyrene. That typically has an R value of around 4 per inch. Your XPS, your extruded polystyrene, typically an R value of around 5 per inch. And then you have your polyiso, which is going to have an R value of 6 or sometimes more per inch. Now, I mentioned it has a very low water resistance rate. So here we have a comparison of polyiso, which is going to have per ASTM a value of less than 2% water absorption by volume, compared to fiberboard, which is in that 7 to 10% range. So certainly much more water resistant than fiberboard. And a lot of these values are, ASTM values. So certainly the manufacturers are going to meet or often even exceed those values. So a lot of your polyiso manufacturers will have less than 1 or even a fraction of a % of moisture absorption by volume. And it's important to note with this test, this ASTM C209 2-hour water immersion test, we're actually taking the insulation and submerging it in water. There's some other boards out there like your mineral wools that don't submerge or totally dunk their insulation in water to get these low values. This is kind of a comparison chart showing the moisture absorption of foam sheathing compared to just some other common building materials. You can see spruce wood, plywood, or cellulose insulation, fiberboard, stucco, polyiso, and red brick clay. You can see there, based on the relative humidity, they all go up, but polyiso is almost as low as red brick clay, not very absorption of moisture regardless of the humidity. Now, what about the durability? Some people, what's going to happen if this gets wet? Again, it's a closed cell material. It doesn't absorb moisture, so it's not going to rot, decay, or corrode. It's not prone to moisture damage because there's no opportunity for it to absorb it, versus other building materials, maybe like wood. You can see here, certainly this exterior wall has gotten wet and really caused some damage and rot there. Some different applications, like I mentioned, it can be used in a variety of different types of construction. So you have here some wood framing with siding on the outside, lap siding. You could also have brick, stone, stucco, really anything, but you can see there the continuous insulation is running continuous across the wood framing members. There is some cavity insulation shown that's required in some cases. Also in steel studs, another great opportunity for continuous insulation. Here we're showing it with a brick cladding. And also in mass wall construction, like your masonry or concrete walls, continuous insulation, and then some furring strips and your cladding over top of that. So a lot of different ways it can be used. Now, in residential construction, different requirements based on which climate zone you're in, but a good chunk and a majority of the folks on this call are either in climate zones 2, 3, or 4, being in the Texas and Oklahoma area. So climate zone 3 and above, you're typically going to have an R5 requirement for 2x4 walls. You can see here a minimum of R5 CI for climate zones 4 marine based on the 2009. Now, if your local jurisdiction is on anything 2012 or later, climate zone 3 and above is going to require that R5 for 2x4 walls. So let's look at that a little bit more. This chart is kind of maybe takes a little second to look at, but if we look at climate zone 1 and 2, the very top one, currently, based on current codes, there's no requirement for continuous insulation in those sections. But when we close the second and third column, we see there climate zone 3 and climate zone 4. So in 2x4 construction, any jurisdiction that's on the 2012 or later code needs that R5 CI for that 2x4 wood stud construction. If you happen to be doing 2x6, there are opportunities to use a thicker bat insulation or more insulation in your cavity to meet the prescriptive code. So definitely something to consider as you're building there. Why is this? Why are we starting to see this push for continuous insulation? Well, you can see here a thermal image of a house. Certainly windows are going to be our weakest link. There's only so much the window manufacturers can do with double paned windows or even IGU's insulated glazing units. But you can very clearly see where the studs are across that house. On the right, by putting a 1/2 inch of foam sheething continuous insulation over it, we eliminate that ribbon or candy stripe effect that you do when you look through a thermal camera, even with wood studs. Now, air barrier. This is becoming more and more part of the code as well. Most of your foam sheathing out there are going to meet the air barrier material requirements. Now, it's often key to seal the joints. These, much like a membrane air barrier or sheet air barrier, these are 4x8 sheets of boards, and the joints in between them need to be sealed, often with tape or flashing. So, for our climate zones 2 through 4, the vapor barrier and such is typically going to be on the outside because the majority of the year, the humidity is higher on the outside than the interior. Now, as you get farther up into the climate zones, there are sections where they are heating more during the year, and that could throw you into having 2 vapor retarders, one on the exterior and one on the interior. We'll get into that a little bit more later. Now, water-resistive barriers. Certainly a foil-faced insulation like polyiso is going to be great for a water-resistive barrier. Obviously, you have to treat the joints. So you want to make sure, though, that the product that you're using is approved to be a water-resistive barrier. Not all have been tested. So like I mentioned, the flashing tape is required, and you want to make sure you're using a flashing tape that's approved and has been tested. Don't go to Home Depot and pick up duct tape. It may not hold. It might solve everything for MacGyver, but not everything for your building envelope. So you want to make sure that it's a well-installed, quality installation. It's going to give you durable, through the testing we do. It's going to make sure that you've got a good dry system when you're looking for a water-resistant barrier. And it's interesting to note that in order for these foam plastic sheathings to be considered a WRB, their testing is actually much more rigorous. The testing for membranes and sheet-applied WRBs, or wraps, if you will, is 2.84 pounds per square foot. For rigid insulation to be considered a WRB, it has to be tested to 6.24 pounds per square foot of water pressure. So it's over double that of what wraps and membranes go through. So you know you're going to get a good quality WRB. Now, energy code compliance. So you can see here the different climate zones throughout the country. You know, climate zone 2, starting really down from the southern portion of Texas all the way over to Florida and a portion of Arizona. Climate zone 3, covering a good portion of the southeast all the way over to El Paso. And then climate zone 4, coming through Virginia, snaking all the way across and hitting the panhandle of Oklahoma, Texas, up in the Amarillo area there. So, you know, so they did some life cycle analysis on buildings in these different climate zones and how much you can save over a 30-year period, the same as here, you know, many people that buy a house take out a 30-year mortgage. And so why you might want to consider using continuous insulation and really how the codes are saving us money. The great thing about continuous insulation is it's a one-time investment. A lot of homeowners aren't thinking that way, you know, and a lot of builders say, oh, well, why don't I put a higher C or AC system in here? Or maybe I'll switch to a tankless water heater. Well, both of those components will probably be replaced at least once, maybe 2 or 3 times in a 30-year life cycle. Continuous insulation is a one-time investment. It's going to be there and perform for that full 30 years. So for instance, you know, looking at climate zones 3 and 4, if we compare IECC 2009 versus 2006, you know, looking at roughly $2,000 savings. If you look at the comparison between 2012 versus 2009, it almost doubles that, you know, $3,600 and $5,300 in savings. So, you know, if you look at the comparison of 2012 versus 2006, even higher, almost triple those values at $5,600 and $7,600. So, you know, granted, this is over 30 years, so the yearly savings is, you know, 1/30th of that, but definitely some great advantages that can be done with our newer construction if we build it right and utilize the codes. Now, understanding the codes, there's 3 basic approaches. Our traditional construction that we've been doing for years is shown on the left. We're just insulating the cavity. We've got our exterior sheathing. In this case, we're showing siding, but you could put brick or what other cladding you want there. But traditionally, we've just been insulating in the cavity. The codes are pushing us to do a combination of cavity insulation plus continuous insulation. So you can see there, you've got the bad insulation shown in the cavity, the continuous insulation shown outside of the sheathing, and then the cladding put on. There are some folks, if anyone's familiar with Matt Reisinger, he's a YouTube building scientist out of Austin, Texas. He did what we see on the far right there, CI only. He did what he called the 500-year house, where he put 2 layers of 2-inch polyiso on the exterior of a wood stud building. There was nothing in the cavity. There wasn't even interior gypsum on that house. Actually got to tour it, and since he shares the same name as me, I wanted to meet him. And so I was in the house for about 30, 45 minutes, and the AC never kicked on. Now, it was, you know, October in Austin, so it wasn't exactly 100 degrees like it might be out today, but definitely warm. Now, there's also 3 paths to compliance or code compliance. You have the prescriptive path, which means the code said you must do this, 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 and this and you follow all of that. So you can see there, you have the R13 plus an R7.5 CI. That's actually probably something that came from a steel stud chart. But there's also performance path, where you take the U value of all the components used in your exterior wall assembly, everything from the interior gypsum, the cavity insulation, exterior sheathing, the continuous insulation, and your exterior cladding. That's another way to achieve code. And then there's the total building analysis. There's things like res check, HERS scores, that'll give you an analysis of the building to tell you how energy efficient it's going to be. And that takes into account things like AC, things like water heaters, you know, all the different components that go up into making a building. So reviewing that, you know, certainly the prescriptive path, the R value path, you know, again, climate zone 3 and 4, you've got R20 in a 2x6 steel stud construction, and this is for the 2018 IECC, or an R13 in your 2x4 construction, plus an R5 of your continuous insulation. Then you have the performance path, or U factor compliance option. And this is where you take the U factor or reciprocal of R value approach. And in this case, the lower the U value, the better. And so you can use this approach to explore alternatives to the prescriptive path. You know, say for instance, you wanted to use all continuous insulation outboard of your studs. You could figure out the U value alternative that would get you to the compliance path. This kind of runs through, you know, the equations for a compliance path method. You know, here we are taking into account, we're looking at a climate zone 4 assembly, and the maximum U factor there is a 0.60. We're assuming a framing factor of 0.25, meaning roughly 25% of our walls have studs in them, and the rest are insulation, or 75%. And so you can see there, we take into account the air film, plywood, siding, the continuous insulation, in this case polyiso at 1 inch, the 2x4 stud, bad insulation, interior gyp board, and interior air film. And you can see there, you know, where there are studs, it's a much lower R value at 12.35, and where it's all insulation, you're up over 20, almost 21. So you can see once you run through the calculations there, the U comes out to 0.053, which actually is lower than 0.060, which is required in climate zone 4. So your assembly works and you pass. Now, you must use code compliant insulation materials, regardless of performance path or prescriptive path. You must substantiate the U factor for the assembly, doing the calculations. You also want to check to make sure your moisture vapor control works. You know, sometimes people go, oh, well, I'll just add more insulation here, and they're not taking into account any dew point or anything like that. You want to make sure that, you know, you create a warm wall assembly, and that's achieved most often by following the prescriptive R values or greater, especially when it comes to continuous insulation. You're essentially putting a koozie on your building, if you will. And then, of course, you have your total building analysis compliance path. You know, it makes full use of trade-offs to demonstrate the full building compliance. You know, certainly you can upgrade things like your AC or go to a tankless water heater, res check, Wolfie, other software out there, including the HERS performance and such. So it's a performance-based compliance, but typically done through software modeling. So section 4, building code compliance. You know, fire has become a big important part of buildings. So fire safety requirements, you know, the materials must be labeled and identified by an approved agency. You want to look at surface burning characteristics, oftentimes ASTM E84. You want to know, does this material require a thermal barrier over it or a 15-minute time-rated material over top of it? In many cases, foam plastic sheathing needs to be covered by a half-inch gypsum. That qualifies. The half-inch gypsum is your thermal barrier or other approved thermal barrier material. But there are approvals such as NFPA 286, FM 4880, UL 1040, or UL 1715 that allow foam plastic sheathing to be used without half-inch gypsum or other thermal barriers out there. So if you have a case, we don't see them as much here in the Texas and Oklahoma area, but if you have a case where maybe you want to do some exposed insulation in a basement or a garage, there are foam plastic sheathings and polyisos out there that can be utilized and left exposed in those applications, or maybe even in a crawl space. Lots of opportunities there. Here we're comparing foam versus OSB. It's interesting to note that most of your foam plastics are going to have a flame spread of 75 or less. Some of them even have a flame spread of 25 or less. A flame spread of 25 or less is a Class A. A flame spread of 75 or less is a Class B per ASTM E84. It's interesting to note that wood structural paneling or OSB, there's no code limits. Although they've looked at the flame spread for it, it's anywhere from 74 to 172. So each manufacturer is going to use a little different formulation for their OSB. And the smoke developed is typically you're going to look for something with 450 or less smoke developed. And some of your foam plastic sheathing, like I mentioned, they're going to need a thermal barrier, typically that half-inch gypsum over them to separate the foam plastic from the interior of the building. There are some that don't. With OSB, very flammable material, there's no thermal barrier requirement in the IRC or the IBC. So it's interesting. We're taking these two components that have similar and flame and smoke developed properties, but one has specific requirements while the other doesn't. Again, not all foam plastic sheathing materials are going to be equal. In the case of polyiso, it's a thermoset material. It's going to stay intact during fire exposure. It's going to remain in place during the ASTM E84 tunnel test. And it's going to meet or exceed your flame spread ratings. Now with thermoplastics, your polystyrenes, your EPS, your XPS, like your polystyrene coffee cup, it starts to soften at about 165 degrees and it starts to melt around 200 degrees. And so when in the event of a fire, whether that's a real world fire or the ASTM E84 tunnel test, it's going to start to drip and it will continue to burn as it drips. It might fall from the ceiling to the floor in that tunnel test and it'll continue to drip as the fire goes on. Structural requirements and wind pressure resistance. The structural code has requirements and they're no different for walls with CI. There's the option to do integration with wall bracing. You must have bracing with or without CI. It really makes no difference. Some people think, certainly CI changes? No, it's still a wall. It must be braced. Certainly integration with the framing requirements, stud sizing connection, wind uplift, things like that. All these framing requirements must be met with or without CI. So we're not changing anything there. There are just some CIs that are able to give you some structural advantages and some wind resistance. For more information on wall bracing, you can look at the IRC Wall Bracing Guide. It'll have design factors and such. Some other code-compliant bracing methods: oversheathing, foam between and over intermittent braced wall panels. Certainly, each method has its advantages, limitations, sometimes even disadvantages. Wind pressure resistance. The 2018 IRC code provision that was supported by PIMA ensures all sheathing materials and cladding meet the wind resistance code. So PIMA, the Polyiso Manufacturers Association, we've done extensive research to make sure that we're going to meet and exceed everything that's available in the code. So all wall coverings or sheathing are subject to wind damage. Tornadoes and even hurricanes that we experience here in this part of the country can certainly come into impact there. Whether it's wood structural panels, fiberboard, or foam sheathing, there's all opportunities depending on the strength of the storm and how the building is built and the wall is braced. There is opportunity for this. Foam sheathing must resist wind pressure as part of the wall assembly. So cladding and furring often secures the foam to resist negative design wind pressure. Typical fasteners are intended for temporary wind conditions. Certainly long-term, stronger winds, little different story. Foam sheathing material must span between the studs and have adequate bending strength. Foam sheathing attachments can be designed for permanent wind load resistance as well. So if you have an area where you've got substantiated high winds, you might want to look at a little higher level of your attachments. Wind pressure code compliance resources, ANSI SBCA FS 100 is a good document. Also DRJ, similar to ICCES, DRJ does research or code evaluation reports. Here you see a technical evaluation report. One of the cool things about DRJ is that they actually stamp and seal with a professional engineer stamp, you can see there, in the various states, their reports. So especially if you're looking at a structural or wind pressure report, might be something to consider looking at the DRJ report for that material, because that means a professional engineer has reviewed the data behind that. Now, wind pressure for vinyl siding, talks about the IRC 2018 for installation over foam plastic sheathing. Where vinyl siding or insulated vinyl siding is installed over foam plastic sheathing, the vinyl siding shall comply with section R703.11 and shall have a wind pressure resistance in accordance with R703.11.2. So certainly gets a little complicated. With all the codes, you have to reference different sections where you're at. Some of the exceptions here, where the foam plastic sheathing is applied directly over wood structural panels, that, if you've got your OSB or plywood behind there. Where the vinyl siding manufacturer product specifications provide an approved design wind load. So if they've done some testing, there's some opportunities there. Or where the foam plastic sheathing and its attachment have a design wind pressure resistance complying with sections R316.8, R301.2.1, the vinyl siding shall be installed in concordance with sections R703.3.3 or R703.11.1. So certainly there's a lot of manufacturers that have done research into this to comply with it. If you have any questions, the manufacturers and PIMA are a great resource for that. Now, several national organizations got together, DOE, IBHS, ACC, FSC, NAHBRC, and VSI, did a whole building wind tunnel test. Here you can see they built a house inside of a testing facility and put it through wind tests. Here we have OSB, wrap, and vinyl. Certainly all the names are taken off this, so you can't see which manufacturer it is. But you can see with the testing, there was some damage. It pulled the wrap and the vinyl off. The OSB stayed fairly in place. When they put continuous insulation and vinyl siding up, the continuous insulation stayed in place very well. You can see here the treated board joints in between boards. So in theory, your WRB is very much in place. Now, in order to get this, you have different cladding attachments, and it's important to hit the studs, especially if you're using a insulation that doesn't have the OSB attached to it. In this case, we can see in this diagram, at the bottom, you have the interior wall, most likely a gypsum, then your 2x wood framing, your cavity insulation in between the wood framing, and then over top, directly to the wood stud, you've got your foam plastic sheathing, your fasteners attaching that, and then your cladding with a fastener attaching back to the stud. You know, most of your manufacturers for cladding out there will state in their installation instructions to attach back to the stud, but sometimes we'll see folks just attach to OSB or plywood sheathing in the field. It's always ideal, especially with your foam plastic sheathings, that you're going back to the stud. So getting into building science a little bit, we'll talk about WRBs, air barriers, vapor retarders, and moisture control. Building science, you know, for years we used to say let our buildings breathe, and now it's a little bit more about build it tight and ventilate it right. Certainly rain and water are a major concern. WRBs have been in the code for a while. Foam sheathing products plus flashing tapes can be your WRB, and it's going to meet the energy code requirements and the WRB requirements, and often it can be a cost savings to the designer or builder. So a lot of folks remember some of the fallouts of the past of insulation, foam plastic sheathing from the EIFS industry and some of the problems they had in the past. Most of the past problems with EIFS have been changed, and the new building codes have addressed that. Other times it was just bad installation, leaky window units, face sealing not done or done incorrectly. So, you know, a lot of folks have a little bit of a less than ideal taste, but there are plenty of opportunities to do this right and make it a good system. I mean, even here we can see the adhesive that was used to put up this system was installed horizontally. Well, except for in a, you know, high windstorm, water is going to run down, not left to right. So, you know, this adhesive should have been installed in a vertical pattern rather than a horizontal pattern to allow the moisture to run down the wall. You know, WRBs are also coming into play. They help address the water fear. Use of WRBs and flashing to prevent water intrusion around doors, windows, and other through-wall penetrations. Certainly required by code now, so that helps out quite a bit as well. Vapor retarders. This gets a little tricky. Again, building science used to say, hey, you know, let my building breathe, but now we recognize that it's better to build it tight and ventilate it right. You have 3 different classes of vapor retarders: a class 1 vapor retarder, which is going to be 0.1 perms or less, a class 2 vapor retarder, which is going to be 0.1 to 1 perms, and then you have a class 3 vapor retarder that's going to be in that 1 to 10 perm range. Your foil face polyisos and a lot of your foam plastic insulated sheathing are going to fall into that class 1 or class 2 in many cases. Again, I mentioned earlier that warm wall requirement. So if you put that koozie around your building, no longer can the heat or the cold as easily transfer through the studs once you put that koozie on or you create a warm wall. So like I mentioned, the higher you go in climate zone, the colder the temperatures are, and so that can change a little bit what you want to do with your vapor retarders. Here they're illustrating in those Marine 4 and higher climate zones, you're going to have an opportunity where you might want to use a vapor retarder on the interior and the exterior. And they're saying, hey, you want to make sure you use this much continuous insulation to create that warm wall, beat the dew point, and then a class 3 vapor retarder on the interior. And a lot of times your latex or enamel paints will qualify as a class 3 vapor retarder. There's also an opportunity to do a warm, breathable wall. Continuous insulation, it reduces the condensation because you're putting that koozie around there. Non-insulated sheathings, there's a greater condensation potential. You know, that's why we used to have gotta let it breathe, was because the heat or the cold could transfer through the stud and onto the back side of the sheathing, giving you the opportunity for condensation. But now that you're putting that koozie or continuous insulation out there, there's less and less opportunity for it. So good building science, build it tight, ventilate it right. Polyiso-CI has a successful track record with that. You know, it's got all the WRB moisture performance testing and has been utilized in that capacity for years. With flexible vapor retarder properties, we can be your full vapor retarder or vapor barrier, semi-permeable to even permeable. So meets any climate or application requirement. Really easy in the southern climate. So, you know, that foil face with a treated board joint on the outside is going to put your vapor retarder towards the outside. And since the majority of the year the humidity is higher, the vapor drive is going to be inward. So it's a real easy concept here in the southern climates. Air barrier, you know, certainly many of your building materials can qualify as air barrier materials: Portland cement, plywood, OSB, XPS, foil face polyiso. Again, you got to treat the joints, gypsum board, even spray foam. Closed cell spray foam certainly qualifies that, and spray foam of open cell variety in certain thicknesses can qualify as an air barrier material, meaning that permeability of less than 0.004 cubic feet per minute. Installation details. You want to make sure you're installing things per manufacturer's recommendations. Certainly, there's a lot of details speaking to just general polyiso and light frame construction in the DRJ TER 1404-04. You can check that out, meet some of yours. Sometimes, you know, people have said, hey, I'm not going to do any cavity insulation, I'm going to do it all continuous. They go with really thick foam. So there's opportunities. Here we have the Department of Energy Building America program. They did the Alaska remote house where they used really thick foam, and so obviously the windows had to be adjusted to fit for those thicker walls. But, you know, in most cases, we don't see more than 2 inches of CI on a 2x4 wall. So, you know, it's no thicker than a 2x6 wall. So fairly easy to accommodate it. Now, if you do have thicker applications of CI, you may need to box out the window and door openings, you know, treat corners and trims, things like that. So I think we covered all these, you know, the role of CI, the types, properties, and definitions, the different applications. It can be just your exterior continuous insulation, but it can also function as a water-resistive barrier, an air barrier, even has the ability to be multifunctional in these regards, and even in some cases can work to be a structural component. We talked about energy code compliance, building code compliance. We took a brief look at installation detailing. So that's going to conclude the AIA portion, or really the presentation, but I'll open it up for questions at this point.
Perfect. Thank you, Matt. That was wonderful. Let's see if we have any questions. I don't see any come through at this time, which means that was a very thorough explanation and presentation. If I do get any, I will send them over to you. Also, I will be sending out your contact information to those that participated, so they'll know how to you know, reach out to you and contact you if they do have any questions come up. And once again, for everyone participating, we will be sending out a course evaluation to everyone that attended today's webinar. And if you do want an ICC certificate, please fill out this evaluation. Also, if you're not interested, no need to worry about that. Our next webinar, we are in the process of scheduling right now. It will be either Wednesday, October 2nd, or Wednesday, October 9th. So please keep an eye out for that invitation. As I mentioned at the beginning of the call, we are dialing our energy codes webinars back to once a month to keep the content relevant and new and interesting. And thank you again, Matt, for taking some time out of your morning to join us and give us that presentation. And thank you to everyone else who joined us for Speak Your Spirit series. And I don't see any questions, so wishing everyone a great day. Thank you, Matt.
Excellent. Thank you very much, Meryl. And like I mentioned, if you guys have any questions building envelope related, I'm more than happy to answer them. And sometimes the best ideas for new products come from folks that have great questions. So any questions you have, please feel free to send them our way. Have a great rest of your day.
Absolutely. And if you could get us that slide deck, we'll go ahead and pass that along to our attendees today.
Coming to you now.
Thank you so much. Have a great day, everyone. Bye-bye.